Unsuitables. Welcome to my channel, Learning Builds Life. Today we are going to talk about nomenclature, IUPAC, which we call UPAC in case of alkenes. Firstly, we will know the full form of IUPAC, which we call as UPAC. PAC, International Union, of Pure and Applied Chemistry. Now we can talk about alkanes before we move on to the examples and their molecular structures. Firstly, alkanes are unsaturated hydrocarbons. Saturated hydrocarbons. Next, alkanes consist of double covalent bonds. Double covalent bonds. That means there is unsaturation. Alkanes consist of double covalent bonds. That means unsaturation is there. Double covalent bonds in their molecular structures. Then, alkenes are actually, they can form a homologous series. The general formula for forming the series is CN H2N, where N starts from 2, 3, 4, and so on, like that. It doesn't start with 1. Over here, N starts with 2. Now we can take a look at some examples of alkenes. Firstly, N equal to 2. That means its formula will be, molecular formula will be C2H4. Molecular structure. We have a double bond. Now we have to check actually the covalency of the carbon. Over here is 4. Its covalency of carbon is 4. 2 bonds here. It means I need to put 2 more hydrogens. And the name is ethene. ethylene. That is the common name. This is the IUPAC name. And ethylene is the common name. Now we can talk about N equal to 3. C3H6. So it gives us this. Now we have assembled the carbons. We will accordingly understand how many hydrogens have to be bonded to each of the carbons. So over here, out of 4 bonds, 2 are already taken away. So we need 2 more hydrogens. Over here, 3 are taken, so 1 hydrogen. And here, 1 is taken, so 3 hydrogens. That means for the leftmost carbon, we will always start taking the double bond from the leftmost side. Over here, the leftmost carbon has 2 hydrogens attached to it, and the central carbon has 1 hydrogen bonded to it, and the rightmost carbon has 3 hydrogens bonded to it. The name of this compound is propene. Move on to N equal to 4. C4H8. Structural formula. Now easily we can identify how many hydrogens are to be bonded, but we have to know one thing, that we have to check 3 things. In case of these hydrocarbons, the covalency, if the covalency of carbon is being satisfied, that is 4, and if the covalency of hydrogen, that is 1, is satisfied, and is the number of hydrogens and carbons in the structural formula matching with the formula number of carbons and hydrogens given in the molecular formula. Like over here, example C2H4, we have to check if there are 2 carbons and 4 hydrogens, and yes, it is there. And similarly, we can check here also 3 carbons and 6 hydrogens. Same over here, we have to check, but first let us draw the structural formula. So we can easily understand the first one has already 2 taken, so 2 hydrogens bonded. The second one has 3 taken, so 1 hydrogen bonded. The third one has 2 taken, so 2 hydrogens bonded. And the last one, the fourth one, has 1 bond taken, so 3 more for hydrogens. The name is butane. Or means this is butane, or but1ene, or 1-butene. Actually, in case of butane, we can make there is another variant, actually, but due to lack of space, I'm just going to draw the other variant structural formula over here, which is like this. we can just check if there are four carbons and 8 hydrogens. Here, yes. And here also, yes. This one is called butane. Or 2-butane. This is another variant, but there isn't actually any change, just a little bit change in the structural format, but there is no change in the molecular formula. This kind of situation is called an isomer when there are 2 or more variants, but the molecular formula stays the same. It is called an isomer. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you.